Oh, your shoes. They match my shoes.
What's that? I'm sorry. Well, Angel walks in and before he even opens up his computer, he grabs one. So I don't know if he always needs it or if he just does that because he does that. What percent is on your computer? What? What percent? Then give it up. Well, someone might. You got 50% left on your computer, dude.
Well, I didn't know I had 50%.
Then why do you grab one every day?
Because it's always dead. But today I was
So wild. I saw that. I don't know what that means.
Yeah, we did it. Bryce is up there. Oh yeah, we hear you guys. Oh, I can just like usually like if weird looking she's like. But then she knows it's kind of like almost matching. What? And the process, I think so. You're caught in the crossfire. Oh man, it's difficult keeping a straight face for when they're like I don't know why do they do that to me? And then I can record it one time.
Good morning, ladies and gentlemen. Take out your periodic tables. Take out your packet. More importantly, take out your computer and get logged into joinpd.com. Put away your headphones. Put away your phones. Let's get going, ladies and gentlemen. Yeah, whatever. Yeah, I'm bringing home a heart-shaped pizza tonight. She might get half.
That's so cute.
Do I get credit for it, even though it was her idea?
Well, I mean, you're bringing it home.
Okay, thank you. Good. I need the bonus points. I really do.
You were going on to the way to get something.
Well, actually, I drive by it when I'm on my way home, but still, it's the thought that counts.
Yeah, you're still stopping, so it's taking right.
Wow, I have a yellow shirt too, Mr. Brain.
Really?
Yeah.
That's funny because when they sold this one to me, they said this is the only yellow shirt in the world.
No. Like we're almost like matching.
Really? Other than we have different clothes on.
Yeah.
Sorry, ladies and gentlemen. Valentine's Day always gets me fired up. Yes.
You're excited.
You need Hallmark to tell someone you like how much you like them on the one day of the year.
Are you excited to go home to your wife who loves you?
Am I excited for that?
Yes.
No. Do I do that?
Yes.
Yes. Am I excited for it? No.
Aw.
So
Watch, when you get to your house tonight, then you'll be a bunch of balloons. Like your house.
if there are, I'm going to be mad because then I got to take and pop them and get rid of them.
Put some helium into your
Okay.
system.
Again, ladies and gentlemen, the last day for any missing work is a week from Thursday. That is 1 week from tomorrow, ladies and gentlemen. That includes retakes on the Unit 7 test. Please remember, you need to bring me your test with corrections done. If you need help with those corrections, I'm here every day before school except for the last day of the week. And I'm here almost every day after school except for the last day of the week. So you're welcome to come in and get some assistance if you need it. Today we're going to talk about and get into, and you are going to be writing electron configuration. So, questions before we get going? Sorry, there's the code. UJXKPK. Oops, sorry, I'm not even showing it to you. There you go. I don't know what Xerically is.
What was you asking?
Things that you don't see. Like we don't see birds or frogs. What is this? That's not real. In case you needed to know.
How many sub-levels are there in the third energy level? Ladies and gentlemen, drag your icon over the correct choice. In the third energy level, how many sub-levels would there be?
When's our quiz for this unit?
Friday.
Wait, what?
Oh my.
You got a quiz on Friday.
We're passing.
You know what? Consider it a Valentine's gift from me.
What?
To show how much I like you guys.
That's so thoughtful of you.
You know what hurts? All right, what's the correct answer? 3. 3 sub-levels in the third energy level. It is easy to remember how many sub-levels there are. It is the same as the energy level that you are on. In reality, you can have up to how many sub-levels? No. Let me rephrase that. In theory, you could have up to how many sub-levels? 7. In actuality, we only use 4 of them. Okay, but there can be up to 7 of them. The 4 that we would use are the S, the P, the D, and the F. This question, there are only 3 of those in the third level. What are the sub-levels in the second energy level, ladies and gentlemen? Now you got to type in your response. In the second energy level, what are the sub-levels that are available for you?
1, 2, 3, 4, 5, 6, 7, 8.
I'm glad you can count in Hawaiian. Good job. In the second level, what are your sub-levels? S and P. S and P.
Oh.
Every level has an S. Every level from the second one on has a P. Every level from the third level on has a D. And every level from the fourth level on, meaning the 4th through the 7th, have an F. They don't always get filled, but they are there. Questions?
Yeah.
How many orientations are there for a P sublevel? How many different ways in space can it be arranged? The correct answer is 3, ladies and gentlemen. It can be arranged along the X, the Y, and the Z sublevel. Any one of those 3. Now, what is an easy way to remember how many orientations there are? Josh.
Add 1 to the sub.
Add 1 to the sublevels.
The energy level.
No, that will not work because technically
Yeah.
in the 3rd energy level, so you're saying to add 1 to the energy level? Figure out how many orientations are? Were you just guessing? Okay. No, I'm sorry. It doesn't work. I had to think about it for a minute, but in the first level, that would mean there are 2 orientations and there are not. What?
Negative.
I know it's the letter L, but again, I don't think many of you are going to remember those 4 quantum numbers in a week. I don't think many of you remember them now.
Oh, is it the
So what is the easiest way to know how many orientations there are for a sublevel? Okay, let me teach this to you. How many electrons fill the S sublevel?
2.
2. How many electrons fill the P sublevel?
6.
6. How many fill the D sublevel? 10. How many fill the F sublevel? 14. Now, if you're confused, we wrote that down yesterday. You go over to the far end for the P's, above it is P6, correct? Above the last D is D10. Above the last F is F14, right? So how does that help us know how many orientations there are? Thank you. The orientations are always half of that because you can fit 2 electrons in an orientation. So if you can fit 6 electrons in there, that means there are 3 orientations. If you can fit 10 electrons, that means there are 5 orientations. If you can fit 14 electrons, that means there are 7 orientations. And I skipped it, but if there are 2 electrons, that means there is 1 orientation. So the orientations are always half the total number of electrons that can fit in that sublevel. How many electrons fit in the orientation of a sublevel? How many? 2. We just talked about that. That was literally what we were just talking about. I must have ESPN or something with the questions. All right, that's it. Questions, ladies and gentlemen. Okay. So, take out that packet real quick, ladies and gentlemen, and get to this page. This is the second worksheet within the packet, so I believe it would be the 3rd page. Now, we went through most of these yesterday in the notes, okay? Let's go to the 2nd page of it, and let's go to aluminum. Okay. Now, aluminum, ladies and gentlemen, has how many total electrons? How many total electrons in aluminum? 13. And for those of you who are unaware where we're getting that number from, that is equal to the number of protons in aluminum. Now, this here, ladies and gentlemen, is to help you understand how the electrons fill. You will never see this again after this worksheet. Go ahead.
What's the C for?
I'm sorry, that's supposed to be an E. 13 electrons, sorry. It's supposed to be an E. Okay? Now you know why I don't use lowercase letters. Okay? So, $13 electrons. So what this is for right now, ladies and gentlemen, is to get you to understand and to see how we fill up the energy levels. We always start with the lowest level. The lowest one is the one that has the least
Oh,
The least energy. And we work our way up from the lowest energy areas to the higher energy areas. Okay? So it takes less energy to put electrons into the 1s than it does to put in the 2s. Otherwise, the 2s would go first. But it takes less energy to start at the 1s. Now we are going to use arrows, up arrows and down arrows, to represent our electrons. So the first one goes in 1s. I don't care if you do up first or down first. It doesn't matter. The second one goes the opposite direction. Then we go to the 2s. And again, the first one goes one direction. The second one goes another. Now again, I am not going to see how you're doing this. So if you do down arrow first, then up arrow, I don't care. Understand, though, they need to be different directions because they are representing the what?
the electrons,
What about them?
their charge.
Not their charge, no. Fourth quantum number.
Their attraction or orbit.
Spin.
Their magnetic spin. Which direction are they spinning? This indicates that they are spinning in opposite directions. By the way, I don't care if you do up arrow, up arrow. There are two different directions within each of these areas. And this is the reason that 2 electrons fit in a suborbital. Okay? This is the reason 2 fit there, because that's the only 2 directions you can go with spinning clockwise or counterclockwise. So that's 4 electrons. Now for the p's, we fill individually first, which means 1 in the x, 1 in the y, 1 in the z. But I still have more electrons to go. Right now I have 7 electrons. I have 6 more to go. So that means I'm going to fill in all 3 of these with 2 electrons because I have enough to fill it. I'm only at 10 when I'm done here. So now the next thing that would start filling would be the 3s. 1 up, 1 down. That is now 12 out of 13 electrons. The last one, ladies and gentlemen, goes in one of these 3 p's. Now, in reality, ladies and gentlemen, atoms are moving, atoms are spinning, atoms are going all over the place. So are electrons. So for us to say, well, if we looked at it, it would be in the px because the px, bull crap. It's in one of these 3 areas. It doesn't matter which one. The atom is spinning and moving through space. So what was on the x-axis 1 minute, maybe on a different axis in another. But if we stopped and we froze them, yes, we would have an x, a y, and a z axis. We would have all 3 of those. Okay? That's all we're saying here. Okay? Now, earlier in the worksheet, I know you probably didn't look at it. I know you probably didn't do it, and that's fine. I broke these out. 2px, 2py, 2pz. You don't have to do that. I don't care if it's x, y, and z. We're doing this so that you can understand that if we were to talk about the electrons, they would go into an x, a y, and a z singly first, and then they would go back and doubly. But we don't ultimately care. We don't ultimately care. So now we are going to write a configuration. So we begin with 1s. What is the largest number you will ever write next to an s? 2. I would think about putting that as a note down on your periodic table, maybe. By an s, you will never have larger than a 2. Then we go 2s. 2. Again, because after the 1s, we go back and we start filling 2 s's. Then we go to 2p. How many? 6. For a p, you will never have a number after it larger than a 6. That is the maximum. That's it. What's the maximum for a d? 10. What's the maximum for an f? 14. You can go lower than those because maybe you didn't fill all of the p's, but you cannot go higher than those. Okay? So what's next? 3s2. Those are filled. Well, then I have 3p1. There is your electron configuration. 13 electrons, you have just described all 13 of them. 1s2, 2s2, 2p6, 3s2, 3p1. You want to make sure you're correct, or you want to at least have a shot of being correct. 2, 4, 10, 12, 13. That's how many I was placing. At least you got the right numbers there. Doesn't mean it's correct, but you got the right number there. Questions? Yes, no, maybe so. Okay, now. What element did we just do? Aluminum. Here's the other thing about it, ladies and gentlemen. Here's aluminum. What group is it in? It's in the P1 group. What energy level is it in? What energy level is aluminum in? 3. How did it end? 3p1. What is bismuth going to end with? What is the end of its configuration going to be?
6p2.
6p, sorry, bismuth, 3. I don't know how you got 2. 6p3. That's how its configuration is going to end. Now you just have to go back and fill in all the stuff before it. We'll show you how to do that. But at least you know you've got it ending correctly. How is iodine going to end? 5 from the energy level, P5. Now again, I didn't do this, ladies and gentlemen. I would maybe suggest it for you on your periodic table over here on the far right-hand side. I would maybe think about doing this. I would maybe think about doing that. Why? Yeah. So you don't have to go all the way back to the other side. Your numbers are over there as well. And here's what happens, ladies and gentlemen. We go to this one, silicon, and you're like, all right, it ends P2, 2P2. Does this end 2P2? No, why? It's in the third energy level, but people start counting down and they forget that there's nothing up here. So they'll be like 1, 2, 3, 4. Okay, so this is 4P2. No, it is not. It is 5P2. Questions? Again, just a hint. Hopefully help you keep it straight. You don't have to go all the way back to the other side. Questions? All right. What would palladium end with, ladies and gentlemen? Be careful. What would palladium end with? What? Good. Put a number in front of it, though. 4d8 or 5d8? Remember, the D's are one behind. The D's are one behind. This would end 4d8. Questions? All right. How about neodymium? Strong, powerful magnet, ladies and gentlemen. How would it end? Somebody. Okay, look at the top. What's above neodymium? Okay, so it has to end F3, correct? What F3? 4 F3. Remember, the F's are 2 behind. Yes, it is in the 6th period. I'm agreeing with you. But in the 6th period, along with the 6 S's, are the 5 D's and the 4 F's. So these last 2 down at the bottom have both D's and F's in them. And the D's are 1 behind, the F's are 2 behind. Okay? Up here, we only have D's involved, and they're only 1 behind. Up here, we don't have either one involved. Okay? We don't have either one involved. Questions? Yes, no, maybe so. All right. So, you want to work at your desk? You want to go write on the tables? Which one? Go start writing them. Go start writing them. Markers are in the back. I'll bring the towels in a minute for erasing. By the way, the numbers afterwards are the atomic numbers to make it easier for you to find those elements, ladies and gentlemen. By the way, if you come across a marker that is dead, throw it out. Don't put it back in there. If you need a towel, come on up and grab one, ladies and gentlemen.
Hey, you.
Which one is this? 32?
Which one? Yes, 32. That's the element number. That's the atomic number. Make it easier for you to find on the periodic table.
And then SM62.
¿Qué dice eso? ¿Qué dice el next question? ¿Qué dice imbécil?
El de abajo.
No, pendejo, calcium.
¿El número?
Calcium 1.
20.
Eso es lo que sí.
I'm doing double because I mean, that's a friend. Sorry. I will send it to my car. But Tom Shitty has no idea why. Okay, well, here's what I would tell you. Always start the same way. Okay. You gotta get to here. You have to tell them all the electronics. What level is it?
I saw it.
If you don't have time.
Yeah. I've done it. I don't know how to have 10.
Can we get by those? That's two. I didn't buy any of them. Trying to get down here. It's two. What are these? She used to work here. What are these? All the way through, right? There. You do not have to do all this. If you want to, you can. All I need you to do is write this as 1s2, 2s2, okay? More than, we did this to hopefully get you to understand it, to see the patterns, to do that. Now, again, this could help you, but again, now. Okay, now here's the problem. This ends in 4p2, correct? Okay, but what did you miss in here? What is in between these four S's and these four P's? How many?
Yeah.
Okay, and what number goes in front of these? D10. Very good. So in the middle there, you need to include 3d10. Okay? 3d10. Now germanium ends what? P2. Which P2? What level is that? 4 P2, not 4 P6. Because you got 2 4 6s. You only need 2. But the problem is, you forgot these, so when you're doing your arrows, you're like, man, I'm out of space here and I'm still short. So you take 6 of these and put them into here, that leaves a fewer amount. What? But these, this D right here, even though it's in the fourth period, it's a 3D. This D right here, even though it's in the fifth period, it's a 4D. The D's are one behind. Yes.
I was studying.
Yeah. Yeah.
I got 6, 7, 2. Right here.
6, 7, 2.
6 actions.
Okay. Yep.
And after that, 5B1 or just 2 or
Okay. Now, because you get beyond these, back into here, you write it the way you did.
so after 6.
14.
Then is 5B.
Where does this come from?
Now, if we had it in here, we would have put the D1 first, and then where we finish in here.
Like 5B1.
5B1 and then like 4F2. Okay? Because we're getting all the way through these, and these are done, we list them first. Okay?
I think that's always the first thing.
Okay, what can I do for you? Okay, so, finding two rest of them on the periodic table. How do you get to it? Alright, put someone's periodic table. So right there. So we need to describe all of the electrons above it for sure. So what are these? Begin with the number, what are they? One what? One has, and how many of them are? So write that down. So anytime you go beyond the first energy level, have your configuration start at next. So now we get beyond the second level, right? To get down to here. So what are these? Look back right here. These are what?
Yeah.
2 what? We always have a number in the letter, 2s. You'll never have a number bigger than 2. Okay. So now what are these? Which these? What number? 2. These. What? Nope. Get all the way to this end, right? What is that?
It's calculated.
Okay, so because we're getting all the way through, because we still need to go further down, the maximum number you will put by a P is a 6. Still do process. Okay, so now what are these? These are P's over here. These are the S's. We're at the my next. Okay, what's next? Nope. You didn't understand the process. What are those? So you gotta get all the way across. And then get to the end. And come back and start over again. So we got all the way across. Now this 2s2, 2p6, 3s2. What number, what letter? When I got the cards, it's good, right? I'm bringing money. Now, here are these. Or ask, what were you gonna pay? Okay, now, we're confusing here. Carry, what are these? What number? 3. D. You get all the way through. Cool. This is in what? Nope, that's not these. Okay, what number P? Wait, I think you and I were saying two different things. Sorry, I want the number in front of you. Okay? Right. And then what number was above it? Okay. 2, 4, 10. 12, 8, 20, 32.
That's a lot.
If it kills you, I wouldn't make you do it again. Well, that's gold. Everybody likes gold. Well, that's the one right above it. That's 47. Try doing the next one. Gotta walk before we can run, right? Yeah, go get your own day clock. Okay, so here's what happens. Can I get Jasmine and we're talking about down here when we get into these. So they, so when we've got the D's and the F's involved, okay, here's the rule. If we're gonna go past the F's, in other words, beyond this one, somewhere over here, we're gonna list them before the D's. So this is what? These two are what? 6S1 and 6S2. We're gonna have 6S2, right? Then the next thing that completely fills would be these completely. So what F's are these? Not 6F's. What F's are these? 4F, 14. And then you would add 5D something. Right? The only time we don't do that is if we end in these down here. If we end in these down here, wherever you're at, that should be the very last part of your configuration. Okay? The very last part. Okay? Correct. So even though F's exist in the fourth energy level, they don't start filling until the sixth.
Wait, what's that one?
The D's are only one line. Sixth energy level.
Yeah.
Right?
Yeah.
There's 41 that means you're gonna have to have ultimately, yes. Now, here's the thing. You'll only ever have one orientation. You'll only ever have three orientations.
No, it's a
That's right. If you want to think of it as
like a
multiple
actual
orientations,
feature
that
factor.
is 20 and a half. You put that
That's fine. They just do that.
unless you know for sure that there's always three orientations, even if it's 5. You're correct, but I don't know. In your mind, if that first something great, I don't know how to help with configuration. Maybe
All
yes, yes. How many are you coming up short? 2, 4, 10, 12, 8, 20, 30. 36, 38, 40, 54, 6, now, 2, 4, 10, 12, 8, 25. All I'm doing is adding up those columns. That's it.
Eric?
Oh, yes, I was wondering, was this right or? Oh,
These two need to be switched.
all switched, okay.
Here's why. There's four S's. I'm sorry, yes, four S's.
Oh, okay.
So you always take them in the order they come on the periodic table.
So that happens first.
Correct.
Okay, got it.
No. It's just those two. Just those two.
Okay.
Yep. Yep. What? Put him in the wrong order? Yes. Well, these are either right or wrong.
So
It's either right or it's wrong.
For example, this, like, we had the right idea, we just had it in order, so that means the whole thing would have been wrong.
Well, if I'm grading you on your electron configuration, yes. Well, it's a cruel, cruel world.
Yeah.
I certainly can.
Because, okay, so.
Ooh, like that. Now you got the basic of it. Good. Now try to do silver or gold or one of those. Skip that and then skip maybe silver or gold. Okay, try to do all of them. Don't write it on the street. I don't want that.
Yeah. Actually, matter of fact, copy.
Four S's is here. Right? Where are you trying to get? What are you gonna get this first? This can never be one. It's always S2. When they're filled, S is always having two. Now, hang on, here's a way. So 1 and 2 is 3, 9, 10, 12, 18, 19. Okay, so here's where you're getting a little too. Don't do this. You would only ever write it once. I might be good. Yes, you don't need to do it twice. Here, this is what you need to do with these. Okay, you did it here too. When you're getting, I see a periodic table. When you get full in areas, here, you don't need to write both of these. You only write down, you write 3S2, I'm sorry, 4S2, 5S2. So when you get rid of something, you summarize it by saying, okay, 4 S's were there. The same way to get past these 3Ds, you just write 3D 10, 1. You don't write 3D1, 3D2, 3D3. Those will get overgot.
So 1 is 2.
Okay. So I like what you're doing. You got the basic idea of it, but again, you can't use this word. So now, are your questions? Take these out. Now, I'm gonna double check. 2. Let's make this a 2. Okay. 2, 4, 10. 12, 18, 20, 30, 36, 38, 48, 54, 56, 61. And there it is. Gotcha. Yeah, so here it is. You were right. 4F5. Absolutely correct. You forget that. That one has to go there, only because you're ending in here. So you have to put that ID1, okay? Alright, otherwise, that's an exception, that's a tough one, you're doing well on it.
No, and the way that you don't write it like that.
Okay, well, this is good, right? So, are we getting through?
Yes.
You were So I think something is.
How we doing?
3 becomes 1. Oh, sorry, I was
Last one.
4, 2, 4, 10, 12, 18, 20. Maybe I miscounted. 12, 4, 10, 12, 18, 20, 30. Okay. The problem is you jumped from here to here. So you went from here to here. What you did, these over here, and these at the start here. So let's take away this. And don't make that jump over 3S. Continue across. What are these? What are these? Then. Okay.
That's why she said.
Let's do it.
What's wrong?
Okay,
So where are we from? Here, right?
Well, first of all, we stopped there. We were right on there. So what are these?
Okay, so I'm getting confused.
We're going beyond this. We're beyond this.
If you ever think that you're doing something, you're missing a C. You're missing. If you work, these girls, you can go to school.
Or, on this one? We're at 3. That's where it gets a little weird. All of a sudden your knees are in a different location. Okay, so what are these? We end here, right? Now, 2, 4, 10, 12,
Wow.
18, 20, 30, 36, 38, 47. All I did was add on the X. It would say spin out. And then people say it's less than 4, it's like 4.
All right, come back, leave, cap your markers, leave them, come back to your desks here real quick. Come back to your desks here real quick.
Oh, okay.
Wait, are we gonna go back to the?
You're going to go back. Just relax. Okay. All right, ladies and gentlemen. Okay. Now, please listen. Some of you have gotten this far, some of you have not. But I want to go through a couple of them. I'll give you a couple more that you can go back and try in a minute. The ones that I want to do are this one here and this one here. Okay? Those are the ones that I want to do. Now, those of you who I was meeting with, those of you who I was talking with, you will hear me say, do you get beyond this point? So when we look at our periodic table, for me to get to element 79 right here, I have to get beyond everything in the fifth energy level. Everything in the fifth energy level. And then I'm going to end somewhere here to be at gold. Okay? So I need to go back and I need to describe every level. And what I mean by if you get past it, we get past 1s1 and 1s2 if we go into the second level. So we are past helium. If we go to boron, we are past beryllium. When you get past something, all you need to do is summarize what that section was. Okay? So, for example, we begin this configuration with 1s2. Why? Because we get beyond the first energy level. We then get beyond beryllium, so then we can go 2s2. We then get beyond neon, so we can go 2p6. We then get beyond magnesium, so we can do 3s2. We then get beyond argon, so we can do 3p6. We get beyond calcium, so we can do 4s2. We get beyond zinc, so we can do 3d10. When you're in the fourth energy level, the 3Ds fill afterwards. We then get beyond krypton, so we can do 4p6. We then get beyond strontium, so we can do 5s2. We then get beyond cadmium, so we can do 4d10. We then get beyond xenon, so we can do 5p6. We then get beyond barium, so we can do 6s2. Now we get into here. Now we get into the part of our periodic table where we're in these lanthanides and actinides. Now here's the rule. If you are going to end up at element 72 to 80 or 104 to 112, means you have to get through the F's on the bottom. You have to get through them, okay? And because you are through them, we list them first, okay? If we were to end somewhere down here, we don't list those first. Then we do the 5D1 first, and then we end with 4F something. But because I'm getting beyond the F's to get to gold, I'm going to list all of them first. So, again, we have 4F14, and then I am going to end with 5D9 for gold. Questions? Now, 2, 2, 6, that is 10. 2 more is 12. 6 more is 18. 2 more is 20. 10 is 30. 36, 38, 48, 54, 56, 79. I have accounted for every electron there. Every one. Questions? All right. So let's try to do the one below it. SM samarium. Okay? Now, again, this starts out identical up to what point? What? Up till here. This is in the 6th energy level. I've got to account for the first 5. Guess what? I can just copy this down. Okay, that's the first 5 energy levels. Now I'm down here in the 6th energy level. I do make it through the 6 S's. So I'm going to do 6S2. But now, ladies and gentlemen, I am ending up, get this out of the way, right here. So I am going to end 4F5. That is how this configuration will end. 4F5. The problem is, ladies and gentlemen, if I write 4F5, 2, 4, 10, 12, 18, 20, 30, 6, 38, 48, 54, 56, this comes out to 61. I am 1 electron short. Where is it? The 5D1. The 5D1. It is this element right here. Lanthanum. Okay? Without listing it as a 5D1, you will be messed up on your numbers. Now, here's what I am going to tell you, and I'm not telling you this to mess you up. There are some people who have tried to simplify this, and they will call this the first F. So literally, this would be F1, F2, F3, F4, F5. They would end this 4F6. I don't like doing that. And where do they put the D? They put it at the very end. I don't like doing that. It doesn't make sense to me because it's not the pattern that we have on the periodic table. But you may see another person, another professor or somebody give you, well, it could also be this. It could also end 4F5 or 4F6 instead of 4F5. We're not going to do that. Okay? We're not going to do that. Questions? Okay. Ooh, do I do it or not? Yeah, okay. We're going to send you back in a second, ladies and gentlemen. We're going to send you back in a second. But when you look on the right side of the periodic table, something is missing. What's missing on the right side? Come on. It's a pretty glaring omission, ladies and gentlemen. What's missing? Joshua.
Is it the numbers next to RN?
Thank you. The numbers next to RN. I don't know. Why didn't you say it now when I'm asking you about it? The numbers next to RN is, some of you have them?
Yeah.
What do you got?
2, 8, 18, 32, 18, and 8. Because I noticed it earlier when you put the numbers on, and I was like, wait, did I put the wrong number in the wrong place? Because we don't have numbers.
2, 8, 18, 32, and 8. Right? Any idea what those numbers stand for?
This one, my old one didn't have it.
Wait, 2, 8,
32, 18.
Whoa. Did you print that new periodic table?
2, 8, 18, 32.
and then 8, and then there's 13 or 18 too. After the 8,
2, 18.
There shouldn't be. Okay, hold
I
on.
have 2, 18.
I have 218.
Okay, hold on.
Yeah. And then after that, it's an 8.
Okay, sorry. It should have ended 32, 18, 8. 18, 8.
18, 8. Yeah.
Any idea what those are? Look at them. Tell me what they are. Come on. See it.
Noble gas.
Oh, you're on the right track. Any idea what those are? Go up to the top. Start from the top down.
2, 2, 8.
What are those? Anybody?
Number of SPEF.
Yeah, but aren't there only 3 S's or 3 P's? You're close. Anybody? What? What?
Well, I'm looking at it from the top, and there's 2 elements on the first energy level.
Okay,
and then
good.
On the second one, there's 2 on the left side, and then 6.
Nope.
Oh,
Nope, sorry. Boy, you were so close. You really were. You really were. By the way, how many electrons fit in the first energy level?
2.
2. 2 in the S. That's it. How many in the second energy level?
Oh,
8.
yeah.
2 in the S, 6 in the P. So 2 in the first, 8 in the second. How many in the third energy level?
18.
Then how come this goes 288? How many electrons in the first energy level? 2. How many in the second level? 8. How many in this third level?
8.
8. 2, 8, 8. 2 and 8.
Oh, each level.
Oh, they're added.
Oh.
If you don't know what I'm doing, add up all of these numbers. It's equal to the box right in front of it, isn't it? 2, 8, 18, 8, 36. 2, 8, 18, 32, 18, 8, 86. Ladies and gentlemen, I'm going to save you a lot of work. I'm going to save you a lot of work, ladies and gentlemen. You're welcome. You can thank me. Okay? You're welcome. You can thank me later. Okay? I prefer chocolates or cash.
Or almond joy.
Don't even think about that. All of this, ladies and gentlemen, all of that, all that 1S, 2S, 2P, 2, 3S can all be simplified into that. And you would finish $54, and 2 is 56, 57, 62. This, ladies and gentlemen, is called a noble gas core. You can only use noble gases. And you have to use the noble gas above the row you're finishing in. Above it. Okay? And this saves you from writing this. You do need to write the row that you are finishing in. We're finishing in the 6th period, so I need the 6S2, the 5D1, the 4F5. But this, ladies and gentlemen, can take the place of all of this. so you don't have to write that every single time. But now those numbers, ladies and gentlemen, that are next to this are going to come in very handy tomorrow. Because when I use this as a noble gas core, these tell me how many electrons were in the first energy level, the second energy level, the third energy level, the fourth energy level, and even here in the fifth. We'll show you why that is important tomorrow. Okay? So if you are doing chlorine, you could begin by writing neon in brackets with a 10 next to it, and then do 3s2, 3p5. Save yourself some writing. Okay? Save yourself some writing.
You can do that all the time.
Well, you can, but okay, does it really pay to do helium brackets 2 instead of writing 1s2?
Well, just with like the big.
But with the larger ones, yes, definitely. Definitely. Oh, I'm sorry. Yes, could you? I'm sorry, I didn't get your time back there, but you got a few minutes. Could you go clean up your area, please? Thank you. Just clean up where you were, erase it, put the markers and towels away. Thank you, Phoebe. You know, why can't you drink soda like a normal person so I can have the can?